This is the second in this video. Let's start. So a review of the indice. So this is the exponential factor, is how much the land is multiplying the potato. This is the power, is how many times you run the farming process. So 3 seasons in this case. So this is the initial value. So how many potatoes do we start with? So this is almost always 1 in mathematics, but not necessarily. So if it is 1, then it's omitted. Can see here because 1 times does nothing, so it's omitted. And when we do not see the initial value, it is 1. Okay. So let's talk more rules for indice. This one, let's look at this first. So x to the power of a bracket to the power of b is equals to x to the power of a times b. Okay. So how does this work? So if we substitute some numbers, let's say using 5 again. So 5 squared. So the 5 was the original exponential factor, and then we run it 2 times, we get 25. Okay. And now the 25 become the exponential factor for the next run. Then we run it 3 times. So we run 25 cube, 25 to the power of 3. And the result will be equivalent to 5 to the power of 6, like this. And how did this happen? So when we do 25 to the power of 3, it is essentially 5 times 5, for 25. And we run it 3 times. So run it 1 time, 2 times, 3 times. And because the multiplication order doesn't matter, so it is equivalent to running the 6 times. Okay, when we run the 5 times 5 for 3 times. Okay, because 2 times 3 is 6. So that's why 5 to the power of 6. And next one. This one is like a distribution. So a times b brackets a power of n. So if we let a be 3, b be 4, then we have 3 times 4 bracket power of 2, which means the exponential factor is 12. And the exponential factor 12 comes from 3 times 4. Then we can distribute the square to them like this. We have 3 squared times 4 squared. And how does this work? Because if we expand the whole situation, so 3 times 4 is the exponential factor. We run it for 2 times, 1 time, 2 times. Then we rearrange, because the order of multiplication doesn't matter. So we rearrange it as 3 times 3 times 4 times 4. This will be equal to 3 squared. This will be 4 squared. So that's why it becomes like this. So that a, b, and n can be any number. And the next one is like the previous one, because fraction is can be expressed as multiplication. So a over b bracket to the power of n is equal to a to the power of n over b to the power of n. Okay, so this will be equals to a times 1 over b. Okay, to the power, bracket to the power of n, and then we distribute n like here. So then a to the power of n times 1 over b to the power of n. Okay, so the 1 still get the n. However, because 1 time itself, no matter how many times, is still 1. So the n just is not necessary here. So it's like, for example, let's say we are doing 1 over 3 to the power of 2. N is 2 here. Okay. So this is equals to 1 over 3 times 1 over 3. And then from fraction, we learned that, okay, denominators times numerators, denominators times denominators. So we have 1 and 3 squared. Okay. So, so you don't see the square here because it's already evaluated. Okay. And the next rule, okay, x to the power of 1 over n. Oh, what does that mean when we put a fraction in the power? So imagine a situation that now we are after season 3. Okay, we have 125 potatoes counted, and we know that we're running for 3 seasons. Oh, but what if we want to find the exponential factor just from these two values? The 125 and 3 is all we have. Can we trace back and find, oh, what is the original exponential factor? The 5 here. So that's a way. If we put the 3 in the denominator of the fraction in the power, okay, it can also be written like this, 125 to the cube root. Okay. These two are the same. 125 to the power of 1 over 3, it is the same meaning as the 125 to the cube root. So, and then we solve this. 125 can be expressed as 5 to the power of 3, and we do the cube root, then it will become 5. Okay. And how does that work? So let's say now x is what we want to find, the original exponential factor. And we are running for 3 times. We know that currently we have 125 potatoes. We want to find x. Okay. Then we do the power of 1 over 3 to both sides, because we are doing the same operation to both sides. And this one of, and both of them are like positive numbers. So then we can like we did not disrupt the balance, so we can continue. Then we use the previous rule, this rule. So x to the power of 3 to the power of 1 over 3 is equals to x to the power of 3 times 1 over 3. And that will give us 1 in the power. Same for the right hand side. Get 5 to the power of 1. So to the power of 1 does nothing. Just like running for 1 season. So then, oh, x is equals to 5. We get back the exponential factor, even if we somehow lost it in the process, but we can like trace it back to get back the original exponential factor of 5. Okay. So these are just 2 ways to express the indice in fraction. Okay. If n is 2, it's called square root. If n is 3, it's called cube root. If n is 4 or more, it's fourth root, fifth root, and so on. Okay. Or we can just use the left-hand side. X to the power of 1 over n. So 1 over 3 here. Then we don't have to use the surd symbol. Okay. So since we introduce a new symbol, although it's just induce, let's talk more about this. So when we see these 4 roots, and we didn't say, well, what's n? So if n is omitted here in the surd sign, it is 2. Okay, this is a square root. Okay. So these two are equivalent, but just we omit the 2 usually if it is 2. But if it is 3 or 4 and so on, then we cannot omit it. So, and it is also be equals to 4 to the power of 1 over 2. All 3 are the same expression. And the answer to this will be 2 or negative 2 if negative numbers are involved. So let's see. So let's say x squared is equals to 4, which means x times x is equals to 4. And what could x be? So 2 multiplied by itself is 4. Negative 2 multiplied by itself is also positive 4. So both of them are valid roots. So, however, if only positive numbers are involved, then this is the answer. If positive numbers and negative numbers are both involved, then this is the full answer. Okay. So see you in the tutorial of Indice II.